All right. Number 5 says Mr. Kwan's boba stand is starting to gain traction and become more popular. He does some analyses and finds that his costs are modeled by the cost function that's given there, and his revenues are modeled by that revenue function. Find the break-even point or points. Now remember, you can think about it in two ways. The break-even point is when the revenue and the costs are equal, or when the profits are 0. So either way you think about it is fine. I'm going to set the revenue and the cost functions equal to each other. So we have 120x plus 15,000 is equal to 370x minus x squared. So I'm going to take the stuff on the right hand side and move that over. So let me subtract 370x from both sides, and then I will add x squared to both sides. So if I do that, then my left hand side of the equation should be x squared minus 250x plus 15,000. And that is equal to 0. Now recall there are several ways that we can think about this problem. I am going to use the factoring method, the x method. So I'm going to put negative 250 on the top and 15,000 on the bottom. And my goal is to try to think of two numbers that add to negative 250 and multiply to 15,000. And the two numbers that do that are negative 100 and negative 150. So now that I have those two values, I can factor my expression into x minus 100 times x minus 150. And that is equal to 0. And now from here, I can use the zero product property and set both of those things equal to 0. Okay, so we get that x equals 100 and x equals 150. What that means is Mr. Kwan would need to sell either 100 or 150 cups of boba to break even. Okay. Example 6. Using the equations in the previous example, find the number of units that maximize the profit and find the maximum profit. Okay, so remember, I gave you that mnemonic device earlier on in order to think about the profit function, and hopefully you remember the mnemonic device. It's people read negative comments, or another way of saying that in the context of business and economics, it's profits equals revenue minus cost. So our profit function is equal to our revenue function, which is 370x minus x squared, minus the cost function, which is 120x plus 15,000. Okay, so now we want to simplify and combine any like terms for our profit function. The first thing that I'm going to do is, it might be helpful if you think that there is a -1 outside the brackets. I'm going to go ahead and distribute to both of those terms. So we get 370x minus x squared minus 120x minus 15,000 So that's going to be negative x squared plus 250x minus 15,000. Okay, so the a value is -1 in this scenario, which means that if we were to graph this, it would be a frowny face, and we want to maximize the profits and find the number of units that will maximize the profits. So just like we've been doing, we're essentially trying to find the vertex of the parabola, and we want to figure out what goes there and what goes there. So let's use the negative b over 2a. We know that's the x-coordinate of our vertex. So our b value would be 250, and our a value is -1. So that would be -250 divided by -2, which is 125. Which would go there. And then if we plugged in 125 into our profit function, and I went ahead and I plugged that into my calculator, and I got 625. So our vertex here has the x-coordinate 125 and then the y-coordinate as 625. So let's write a little sentence that says, Mr. Kwan will need to sell 125 units or cups of boba to gain a max profit of $625. Okay. All right, let's move on to example 7. It says, if the demand and supply functions are given by those equations, find the market equilibrium. Okay, so one of our equations is already solved for P, which is nice, but I'm going to take this first equation here and I'm going to solve that for P. And if we solve that for P, then we end up getting P. I'm just going to subtract the Q term to the other side. So we end up getting P equals -1/10 Q squared plus 1,000. Now that both of our equations are equal to P, since both of them are equal to P, what we can do is we can set the two equations equal to each other. So I'm going to set this part here equal to this part here. So let's go ahead and do that. I have 1 over 10 Q plus 10 is equal to -1/10 Q squared plus 1,000. Now, I'm not a big fan of fractions, so in order to get rid of the fractions, I'm going to multiply every term by 10. So I'm going to distribute 10 and multiply it to that term, to that term, to that term, and to that term. And if I do that, we get Q plus 100 equals -Q squared plus 10,000. When you multiply something by 10, you just add a 0 to the end of it, unless you're talking about fractions. Anyways, now I'm going to move everything over to one side. So I'm going to add Q squared to both sides and subtract 10,000 from both sides. So if I do that, then we get Q squared plus Q minus 9,900 is equal to 0. All right, so instead of trying to use the quadratic formula first, I am going to try and factor that using the x method. So I'm going to create my x, and I'm going to put 1 on the top and negative 9,900 on the bottom. And I'm trying to think of two numbers that add to 1 and multiply to negative 9,900. And the numbers that should work are 100 and negative 99. So now I can go ahead and factor that. I'm going to bring that back up here and say q plus 100 times q minus 99 is equal to 0. And then I'm going to use the zero product property to solve for q. Okay, so we get that q is equal to negative 100 and q is equal to 99. Now, in terms of economics, when we're talking about supply and demand, the p variable in these equations represents the price, and the q represents the quantity that we need to sell so that we reach market equilibrium. And in the context of economics in these types of problems, when we're selling items, it doesn't make sense to say that we need to sell negative 100 number of items. So this solution, when we got 2 of them, the negative one doesn't make sense in the context of this problem. So we only want to concern ourselves with the positive solution. Okay, so we have the quantity that will give us market equilibrium. Now we want to find the price that will give us market equilibrium. So I'm going to plug Q equals 99. You can plug it into either equation, but I'm going to plug it into the linear one because the quadratic one I think will get a little bit uglier. So I'm going to plug it into the linear equation that we started with and then solve for P. So our price would be $19.90. Let's go ahead and still write a little statement. We can say we will reach market equilibrium when we sell 99 units at $19.90 per unit.